Okay, so welcome to the geometric method type A, thickened 2D for the 3D print workshop. So I'm going to show you a few of the techniques for modeling this type of geometry in Rhino. And I just want to point out before we start, these are the rules you want to follow. So we're going to use, in this particular case, this dimension of a kind of bounding volume, 3 by 3 by 1 inch. And I also just want to point out, again, we want to make sure that we have a module that's connecting to itself on at least 2 of its 3 kind of planes there. So if I go back into Rhino, first thing I want to do is set my units. I'll just type in units in the command line there, drop down from model units and choose inches. That shouldn't matter because there's nothing in my file. Okay. And what I want to do first, I'm going to orbit into 3D first. Again, just hold Control Shift right click and drag, or you can always go up to the standard toolbar and grab the little orbit to go to orbit into a 3D view from like an orthogonal view. And I'm actually going to start by modeling that bounding box. I'll type in box. I'm going to start at 0, 0, 0, 0. 3, 1, and 3. And I'm actually going to go into top view here. Or I'm sorry, into front view. Now I'm looking at my bounding box face on. I'm going to go ahead and organize my layers real quick. So I'll make one called bounding box. And I'm going to make one called geometry. So this one's actually really easy. There's a few basic things you can do, and I'm just going to sketch in 2D real quick to explain some of the basic techniques. So I'll go back to top view here. So basically what we're doing here is we're kind of combining two separate kind of 2D tiling patterns based on our 3 by 3 grid here, in essence. So with a grid like this, there's a couple of different ways we can think about kind of carving or cutting away the faces. So I'm just going to use a circle here for now. So one thing we can do is we can draw a circle in a particular location relative to the rest of the geometry. And then we can just copy that for each edge. That circle's a little too big. If we rotate it around the center point of one of our volumes, 90 degrees, copy it each time, you can see that if we combine that with our shape, it should make some type of tile that when we start to aggregate with it, it'll produce a larger pattern, like so. So you can see there's a kind of larger pattern that emerges from the kind of voids or the collections of voids. The other thing I think we can do is if we choose to make that pattern off-center or irregular in some way, we can still then rotate it around the center point. But what will happen is it changes the way that our kind of tiling system will work. So if I copy that guy, now when I go to tile it, I've kind of offset my grid basically. And so you can see even with that kind of tiling pattern, we're still kind of generating a series of voids that repeat. We're just not kind of strictly adhering to a particular grid anymore. So again, one technique is just to basically rotate, use a void and then rotate it around your basic shape. The other thing we can do is, and I'm going to make an ellipse here, is we can draw around the vertices of the shape. A little big there, let me just scale that. And so we can play around with kind of what that looks like. But if we draw around one of the vertices of the shape, and instead of, so again, we could actually just, rather than drawing the shape on an edge, we could still do our rotation trick, right? Rotate it 4 times. And then we have a shape that we could tile with. But, so the other option, rather than to rotate the shape, is to copy it in the same orientation. I'm just copying it there. And this will actually produce kind of a true, let me just do that one more time. This will produce, you know, more kind of precise, or I'm sorry, it'll produce a more regular void, basically. And so if we do that kind of thing, now when we go to tile with this shape, you can see it produces a kind of perfect replication of that void, right? Because we've moved that void relative to the block in every corner to the same position, basically. You know, basically this has to do with the intersection of a set of with a grid and a set of subtractions. And so with a thickened 2D, we're moving kind of a half step beyond that, beyond just like a kind of 2D tiling pattern. And what we can do is we can actually combine 2 sets of kind of 2D tiling patterns. So now if I go back to my front view here, and let's say I wanted to do exactly what I just described, which is to draw like 2 kind of 2D patterns. And again, the shapes can really be anything. You don't want intersections like that, though. That's kind of not great. So you can draw kind of an amorphous shape if you want to. And I'm just using interp curve here. And then you're going to draw a second shape. Again, you want to draw 2 closed shapes. So now if I go back into top view here, and I can again hold Control Shift right click or hit the orbit button, I've got my 2 outlines here, you know, just like I was drawing in top view, kind of oriented around one of the corners of my volume there. And so we're going to do the same basic operation. We're going to trim away this shape from the volume. So I need to grab one of these surfaces, or I'm sorry, one of these curves. And I'm just going to use the move command. Again, if you drew your box at 0, 0, and you were in front view, and you avoided snapping to anything, both of these curves should be on that plane there. If you didn't, what you can do is go back into front view there, select either one of the curves if they're not at 0, and type project to C plane. I usually like to delete input just so I don't have duplicate curves, and then it'll bring it back into that plane. So what I'm going to do, again, I'm just going to move this to the other edge of the box, and then I'm simply going to make a lofted surface between those 2. So I'll select the 2 curves, type in loft. We want to leave it on do not simplify. And you know, you can double check that there's no kind of weird stretching or twisting that's going on like we have here. So if I wanted to fix that, for example, what I would do is, I'm going to go ahead and close this. And so, when you select one of these curves, you can see it has a series of control points. And the spacing of those control points is actually what determines how it tries to draw a surface from one curve to the next when you use loft. So what you can do is go ahead and select both of them and just type rebuild. And under point count, that determines how many control points each one of these curves has. I'm going to go up to, I don't know, let's try 20 or something. Quick preview there. Again, we can see what the original curve looks like and what our new curve looks like. We can try maybe a little bit more, a few more points. And then the other thing is, you'll notice there's this degree option. Basically, a degree of 1 is a polyline. So it's a series of straight line segments that are joined. And a degree of 3 is a curve. So we always want to leave that number either at 3 or 1, depending on what we're doing. And then once I'm kind of happy with how closely these two curves are matching, so I could actually go up even more, see if I can get it even better, I'll click OK. And now when I select these two curves and turn on or show their control points, you can see I have a new set of control points and they're more or less evenly spaced out. And because each curve has the same number of control points, it should be, when we go to loft it, again, you can also adjust the start and stop point of the loft. So if I loft it like that, again, do not simplify. Now we have a lot less twisting going on, as you can see. If I were to move those edges, oops, I just flipped them. Let me show you what I mean. So before I hit enter again, I could move these. And you can see when I do that, it starts to twist again, right? Because one loft starts here on this curve, and it's meeting that curve at a separate point. So what I want is to just leave those aligned or make them as aligned as possible if they don't automatically get aligned. Again, do not simplify and click OK. And so now we're just going to repeat the same exact operation. Either you want to rotate it around the center point of the box. If you want to find the center point of this box, you can use the command volume centroid. And what that will do, if you go into wireframe or ghosted, excuse me, you'll see it created a point in the very center of that box. So if I wanted to do the rotation like I had done on the 2D pattern, I would just use the command rotate 3D, snap to that center point, draw a rotation axis straight out, straight up along the y-axis. Make sure I got copy turned on, and I could copy it 4 times. The other thing that you could do, if you didn't want to try the rotation, would again just be to copy that same shape to each of the 4 corner points. And then once you've got your shapes set up like that, what I like to do is just do a kind of Boolean operation, because it should be the quickest and cleanest. Again, this will only work if you have a closed set of geometries. It'll only work if this surface is going all the way through. So in other words, if you don't see it on this side, or if it's not coming out on this side and on this side, a Boolean won't work. So we want to go ahead and select all these surfaces, and I'm going to use the command cap. And again, as long as those curves that we drew to create that surface were planar, it should cap those openings, because the openings are planar. And then when we're ready, we go ahead and type Boolean Difference, which means we're subtracting one thing from another. I select the volume I want to subtract from, which is my bounding box, and then those 4 surfaces that I created. And so now we would be able to do kind of the same thing we had done before, which was to make that kind of tiling pattern based on repeating this module. Now I do want to make the point that once you get to the next tutorial, which is helping you set up your geometry for 3D printing, you're welcome to carve away some of the face of this geometry or do whatever you want. You don't have to be strict about what operations you're following in this sequence of tutorials. But when you go to print, you'll probably want to reset that orientation to something that makes more sense on the printer. And for example, right here, like I would want to leave it in this orientation, because if I flip this guy, you can see right there, because of the way that geometry is kind of branching out or hanging out, out over space. If we were to print this module in this orientation, we would find that the print would fail, because there's this part of the geometry would start just printing out in space. So again, one thing to test before you get too far with any one geometry is how printable is my shape, right? And there are things you can do to make that printable, right? I could add support. I could add some support underneath there in order to hold that guy up so it can start printing, when it reaches that level. You may also find that it's going to save you more time and effort if you just kind of modify your geometry to be more printable. Okay, so that concludes this tutorial, the thickened 2D tile, and I'm going to sign off.